Okay, for number 25, the simplest way to do this is to go ahead and just multiply out and get you a single quadratic. I'll show you another way afterwards that you could have chosen to do as well, but I'm going to go ahead and do it by multiplying things out first. And so that's going to give you x squared minus 8x plus 16 plus 4 times x minus 4. Let's do distributive property now. So 9x squared minus 72x plus 144 plus 4x minus 16 equals 0. So that gives me 9x squared minus 68x plus 128 equals 0. So that's not a real pretty thing, but we can use the quadratic formula on it. So if we use the quadratic formula, we get x equals a negative b, so 68 plus or minus square root of b squared, 68 squared, minus 4 times 9 times 128, all over 2 times 9. Well, so we're going to need to do a calculator to figure out what that discriminant is. So 68 squared minus 4 times 9 times 128, and we get 16. And so this actually just turns out to be much nicer than expected. 6 plus or minus square root of 16 over 18, which gives us 68 plus or minus 4 over 18. So it's nice that that square root turned out to be an actual perfect square. And so that gives us just 72 over 18 when 4 is positive, and 64 over 18 when 4 is negative, which is 4 and 32 over 9, which are the correct answers. The other way you could have done this is you could have started here and you could have factored out an x minus 4. And if you did that, what you'd be left with is 9 times x minus 4. And then what's left here is just plus 4. And so then we simplify this. We get x minus 4 times 9x minus 32. And so from there, you can see where you get the x equals 4 and the x equals 32 over 9. But you certainly could have just done the quadratic formula and gotten to the answer, and that's no problem. Okay, for number 29, this is the one where I suggested start the problem by turning it into a quadratic by letting y equal x squared. And so we do that because y squared then would be x to the 4th. So you'd get 4y squared plus 21y minus 18 equals 0. So now let's do the quadratic formula. So y is going to equal negative 21 plus or minus square root of 21 squared minus 4 times a, which is 4, times negative 18, which is c, all over 2 times 4. And so that gives me negative 21 plus or minus square root of, okay, I need to figure out what that is. So I'm going to do it in my calculator here. So 21 squared plus 16 times 18. Notice that you've got a negative and a negative, so it just is going to get added together. And that actually turns out to be 729, which in and of itself is a perfect square, that is 27. And so negative 21 plus or minus 27 over 8. Just like we did on the last problem, that means you're going to get negative 21 plus 27 over 8, negative 21 minus 27 over 8. And so that gives us 3/4 and negative 48 over 8, which is negative 6. So that means that y is either going to be 3/4 or y is going to be negative 6. And so this is a part that's often forgot, is you do have to go back because you're not trying to solve for y. Y was something we created. What I'm trying to find is x. And so I know what x squared equals, so I can solve these two quadratics, and so I take the square root of both of these, and that's just going to give me, and remember, always add the plus or minus root 3 over 2. So that's 2 of my answers. Over here, when I take the square root, well, what happens? We get an imaginary answer, and so there's no real solution. So it turns out this one, even though we maybe could have expected 4 solutions because we had a 4th degree polynomial, only has 2 solutions because 2 of them are imaginary.